Okay, so now we'll start our session. And so, Professor Predrag, please you continue.
Plan is to work on junk neural networks in morning, and I hope that both topics will be useful in your research. Facts about junk neural networks. Here I will put basic formulas which we will use later. It should. First step is to define appropriate error function. And second step is to define ZNN dynamical evolution. Error function is denoted by E of t, but opposite to gradient neural networks, error function can be scalar value, can be vector value, can be matrix value, tensor, of course. T. Here we will not use Frobenius norm as goal function. E of t is function which we want to minimize. Better to say we want to force error function E of t to 0. Again, error function should be defined in this way that such that 0 of this error function gives solution of our problem. Matrix valued. We will start for scalar valued, then matrix valued. Sometimes we will investigate vector valued. All three types we will investigate. Second step is expanding formula 1. This formula gives ZNN dynamical system, simple form, dot of E equals minus gamma E of t. It is linear model. Non-linear model assumes what we need for different color. You cannot see. I wanted formulas. We will use or put. It is linear model. Non-linear model assumes application, activation function. Story about nonlinear activation is the same as in GNN model. Gamma, gain parameter, should be defined as large as possible. There is analytic solution of linear Zn E of t equal to 0 initial stage times this power. Analytical solution is E of t equals E of 0 times exponential function. Put E of t here and you will obtain this dynamic. What can we conclude? ZNN dynamical system is continuous time dynamical system. This dynamical system is recurrent because from one time instant we will go to another time instant until we complete predefined time in continuous time recurrent neural network with exponential convergence. It is, of course, exponential convergence rate when time goes to infinity of analytical solution to 0. Here I will put. We want to force E of t to 0. And we will define the matrix E of 0 defines kind of solution. But in fact, we should obtain 0 independently of initial. Here are definitions of main error. Here is two error functions. Third column will present limit. Such error functions we have no better in computing matrix inverse than this error function. So, ZNN model is aimed to solve, manipulate with time varying problems using requires big computational complexity. Then again, apply method which we want to apply to another time instant, and here is error function a b minus b. I will skip t. T is assumed. It is, this error function is aimed to solving solution. A dagger b is so-called, we know this from theory, best approximate solution, minimum norm, is when A star A is invertible matrix as A star, of course, of T is assumed A when time tends to infinity, solution will be A star A minus 1, A star E also, left inverse of A. This model is applicable in case when A star A is invertible. What is with rank of matrix A in this case? Rank of A star A must be invertible. A star A must be invertible. It means that rank of matrix A is equal to number of columns. This model is not applicable. There is dual case. Of T A star is transpose and conjugate transpose matrix. We will have A transpose in real matrix case. This is equal to A star times A star minus 1. It is Murpenrose inverse, better to. And this model is applicable in case when A star is invertible. Rank of matrix A should be equal to number of rows. A star is m times m. If not, model is not applicable. If we have a case when matrix A, we will apply well-known strategy during our course as Tikhonov regularization parameter. And this regularization parameter lambda should be small. For example, 10 power minus 4, 10 power minus 6. If necessary, you can reduce regularization parameter. If you don't obtain, if you cannot obtain better results, then stop with reducing. Solving nonlinear equation, f is function which corresponds to solution time varying square root e, and a can be matrices. We spoke that all. Here is explanation why to use time varying models. It is clear that many biological systems are time varying. Many models in economy are time varying. Model in time varying case. Such time varying systems typically are modeled using is one of possible approaches in solving time varying problems. Of course, we can apply ZNN modeling. We can apply GNN model in a time varying case. Again, it is not typical application of GNN model. Sometimes GNN in time varying cases will work. Sometimes will not work. General rule is apply GNN model when problem is constant, independent with respect to time, and apply ZNN when we want to solve time varying problem. And here is our first case. We were aimed to find the inverse of scalar value. And previous based on error functions 3 and 4. We can repeat quickly development of such ZNN models. So who is willing to help me to develop ZNN model for error function E of t? All is Raul, can you try? Huh? You're better in electronics. But such models can be used sometimes. Time varying problem. Do you have time varying problems? It is not necessary for you. Please use chalk and use right part for development. Here is ZNN model. Time derivative of scalar value is equal to minus gamma E of t. That problem is in scalar case. Typically, bold will be used for matrix case. Yes, we need first to. Previous time we skipped of t, assumed that all these values are dependent on time. But it seems for you it is easier to write of t. It is x. And then expanded form, derivative. And our goal was to put x dot left, left to save x dot. And what we did, this model is in implicit form with respect to x dot. To obtain added x dot left and x dot right. Then here we'll obtain x dot, and after that integrator to obtain x. Input of integrator, of block integrator, is derivative of x. Output is x. Only x dot left. It is typical approach when we have such models. Something multiplies x dot, or x dot multiplies something. Typically will be necessary to add one term x dot left and the same term x dot right. Or can put down, no problem. It is ZNN dynamical system 7. Is it the same as 7? Looks excellent. Looks excellent. Okay, we will analyze first. Will help, of course. Here is definition of E of t. We need, it is PDF. We need Simulink. Very small resolution changed. Just a moment to find in Infinity folders. Can be bigger, of course. we will start from beginning and investigate this. I must show in table. First block clock, which means that this block will change during time. And it is interpreted MATLAB function, which means that inside is definition. Input of this definition of this interpreted MATLAB function is time. Output is a double click. And here is a standard MATLAB function with Professor Safik. You had such definition of MATLAB functions. Output, input is time, and here is definition. A is defined as sine of 3 times t plus 2. We used sine of 3 times t minus 2, and Mathematica worked correctly. Mathematica is right. We will see afternoon. I was thinking about this, and Mathematica is right. It was not error. We will see the afternoon. Then what we have times block for multiplication, and both inputs in this block are equal to, both inputs are, a is here. Why a? Because our function is defined as a equals, and we expect that error of this function is a. Use a once, used a second time. Product is, of course, equal to a square. Then we need term. Different model. I didn't. Of course, I will close this. It will be later. It will be later.
This for what?
I had problems with many files for today. Prepare for 1 hour is easy, but prepare for 5 hours and 30 minutes, not easy to be ready for all files, for all folders. Here is our model. About interpreted MATLAB function, nothing new. Sine 3t plus 2. In our case, we need better to be here. We need a dot x. Is a dot x here? Can you show where is? X is output from integrator. X dot is input of integrator. And we use this input of integrator in this product to obtain 1 minus a of t x dot. Here is 1 minus a of t x dot. It should be with sign plus 1 minus a of t x dot. Then we have another term, a dot x. A dot x, we must form product a dot x. A dot, for a dot we need function MATLAB block, simulating block, which makes derivative of input, makes derivative of input. du by dt is only outside visible for this block. This block is aimed to make derivative of input. This block here we need constant 1 to define 1 minus e of t. And then after that, multiply 1 minus e of t by x dot. And in that way, we obtain first term with corresponding to cyan plus, to cyan plus 1 minus e of t, x dot of t. Then next term, minus a dot x. A dot, derivative of a, x. X is output of integrator. After integrator we have x. And used x here in this simulink 3 times. Once to define a dot x, another time to put x in workspace called x. Later we can plot x. And third time we used e of t to make plot of behavior. Here we will instantly obtain plot. If we use this to workspace block, we will be able future to investigate behavior of our output x of t. And third term equal to minus gamma e of t. Minus gamma e x ax minus 1. Minus gamma ax minus 1. First we need to define a, x. X is defined after integrator. It is fourth use of x. Ax minus 1. What is with gamma? Double click here. Gamma. It means that we should define gamma. Is it correct to use ax minus 1 here? Is it mistake? And then gamma. It is the same as we use minus gamma and then 1 minus ax. Then corresponding outputs for gamma atx minus 1. What is with integrator?
Gamma is scalar, so if you multiply from right to left.
Gamma should be defined in command line. ax minus 1. Here is ax minus 1. But after that we have minus, okay. Here is gamma. But later gamma ax minus 1 goes to minus. Where is to minus? So it is correct, goes to minus gamma. If we change minus plus, we will need here plus, we will need here plus. And in that way, we will have here with cursor, we will have 3 terms which define our right-hand side in ZNN model. This time interval. Time interval is 10. Here is very small font. Probably my MATLAB is not excellent. Such long time interval, because function which we consider is a trigonometric function, and we want a longer time interval to trace behavior of error function. In very small time interval, we will not see behavior. We need a longer time interval. So we need to use command line. Here is our ZNN model. I will close this, not necessary in this moment. And here is command line in which we can define gamma. Here is actual input. For example, 10 power no, big time interval requires here we require bigger values. Something with small value we can try, of course, later with such small values. Please, you can define here gamma with 2m, enter. Defined. It is command line. We need to define what is necessary in our Simulink. not need to be defined. Initial state, leave one value, and used MATLAB function rand. We can use another what we want. Random is chosen here, and in each evaluation we will, I think we can start this green, green. Ooh. Is gamma defined here? Yes. Oh, I'm not here. Open again. Goes. A number of tutorials will increase exponentially. Of evaluation. We had only last of evaluation, not complete graph. And now we obtained behavior, periodic. It is norm. Fast convergence to 0. Values gamma compare this behavior and so on.
E of t, then how will be taken for either.
E of t can be matrix. We will see later too. 5 with error function 5. We tried with error function 4. Will be made in. Who is able to help me in development of model? Okay. Please, possible. Why not? E of t is defined as in 5.
So that life should come. You keep on
During this time. You can start from here. Close. Right hand side. Here we can do. Here will be simpler. Denominator. Yeah. Is it the same as 9? Yes, looks. X square times a or a times x square is the same. Here is commutativity. In matrix case, it will not be the same. Matrix case is more difficult because that we will have no commutativity. A number of error functions will be bigger. Here is, I hope here is ZNN model. Gamma x squared a minus x goes with minus a dot x goes with minus also. Both times we have minus because of that. Here we have minus minus block. And we can analyze again what is inside. I think with the same gamma. Gamma again. I think gamma is defined function, the same function. Here is another part of Simulink where we define a of t minus 1 by x of t. Why we generated this for analysis? It was our error function. And here we wanted to consider behavior of our error function. I think gamma has been already defined. Again, short interval for tracing behavior. Again, we need to increase this. I will try with one. View. Configuration properties. I will add here 2 zeros. Probably I don't use last version of Simulinks. Running will give new value because initial state is randomly generated. But in general, it should be only in beginning. During time, we should obtain good approximation of our error function, of our function, which of our scale should be the same.
How do we know that we are getting different answers
Kako?
for A of t?
For A of t, as we want, scalar value can be different. We can change here, for example. Can be, I will use something with the division by 0. By 0, I think. I change the function. Try. To obtain graph of 1 by t minus 1. And of course, we can change error function. Something in this form. Save. Dimensions are no problem. Save. Try to change the save and evaluate. Mhm. Okay. Something with dimensions.
It may be a simple function. One of
What is with? Aha, it should good. Started and then we have not good behavior. Change again, error function. Run. It works. Okay. Do you have more questions?
maybe we can take
Time varying. Typical application of ZNN model is in time varying case. Okay. More questions? If no, we can continue in matrix case to consider.
Can we find the complex complex answer with using the similar?
Our model should be changed to apply complex model. We will need to trace a real part and trace imaginary part.
So according to need, we need to change our model. Our matrix. We have different
Vector
models.
or matrix. For a matrix case will be different because we have no
3 models. We demonstrated 3 models.
4, I think. We had here 4 more. Here are. This one we didn't consider. Is first one, of course, simplest error function. But sometimes we obtain relatively simple values of best choice is first error function. Fine. It assumes x squared is different than 0. We presented here 4 different error functions. First one is for future usage, best choice, simplest simplest model. We presented 3 more models for investigation. I wanted to show that error function can be defined in different ways. Why to use second case or fourth case when first case is simplest? More questions? Can we go to matrix case? In matrix case, we need to define error function. Of course, error function is in matrix form. Now A of t and x of t are matrices. I is identity matrix. And beside error function ax minus c, we have another case xa minus I because of non-commutativity of matrix multiplication. Another 3 models possible to use, but of course, best choice is to use first two models. Here I put 4 more error functions, and we will develop 4 more ZNN models only to see possibilities. In future, we will use first 2 models. Sometimes we will need a formula for differentiation of matrix inverse. We will put this formula because it will be necessary. A minus 1 dot equals of t. A minus 1 of t, A dot of t, again A minus 1 of t. Then you can see that usage of matrix inverse really makes difficulties in ZNN model, and this ZNN model will be more complex. (12) and 13 are best error functions used for finding matrix inverse. Imagine that we use formula 17, for example, with matrix inverse, then we will have such rule for derivative of matrix inverse, and then product of 2 matrices. We can try to develop ZNN with the error function 12. The same rules as in scalar case. Rules are the same. Yes, I suppose you can do this. Error function is in form 12, for example. Shaman. Yes, plus, the same as in scalar case. This simplest natural case.
You can take 5 minutes break, then start 10 minutes break.
We started already. No problem. No, we started now. Take break is not good. We will finish 10 minutes earlier because we already started. Here should be. Now I hope I found last version. Okay. Derivative of error function. Okay. Okay. Put x dot left. Okay, we can move this term right. Only save x dot left. Can do this later, of course. Plus, no problem. Can stay. Plus x dot. Probably you want to add x dot on. Okay, okay. One step more.
We should directly use the inverse of
Inverse.
It will be like
X of t will be our approximation of inverse. Why? Because a x minus e will be forced to 0. And then x of t will be approximation of a minus 1. Excellent. Then only x dot left.
and everything will be this one. So
Another part.
everything is minus, so we keep this here. Everything will shift here.
You want, oh, okay. In this Simulink, we used a situation with minus gamma.
We shift this side.
Uh-huh.
Then it will be
Uh-huh.
I minus.
Can be remove. Of course, situation will be the same, but because of simplicity, we want. Because we will open many ZNN models. Here is simplest model, natural choice for error function. I wanted to show flexibility of ZNN model, different error. What we have, I minus a x prime with plus. Do we have a prime x have gamma ax minus I with sign minus plus? And it is what is in left hand side, x dot. What we need after x dot? We need integrator first. Initial value here is again randomly generated matrix, rand of 2. It means that each time rand of 2 means each evaluation different starting point. Okay, now. How many plots we can expect here? 4 plots we can expect. MATLAB will make plot for each element of matrix A of t. Here, you can expect. Is gamma defined? Gamma is not defined, but 5. Thank you. Double click on scope for blue line, and there are 3. Command line, and we will use command plot x. Okay. Then we can reduce gamma. Here is, now we have still convergence to 0. Try here only one model more. One model with, again I will say, best choice is first or second error function. Function 14. Nothing easier. If I write, you will say it is fast. We cannot understand. Try. Huh? Fourteen. No, no, it ends. It ends. Previously was switched on. Is derivative of a minus 1. Okay. Remove a minus 1 first. In inverse, of course, it is not excellent choice. Finite choice. Another error function are used to show that we have another possibilities.
Multiplying a of 2 both sides.
And right.
Left and right.
We can do this successively. We can do this immediately. We will multiply this side also. Minus gamma can go in front. And now multiply. Can I say minus gamma can multiply a
A of t x dot. Okay, this one. Here we can use x dot t. Ax equal to x.
yes. Of course, more complicated error function, more complicated ZNN model. Where is this x dot?
Axa.
Aha.
Now what to do next? Then we multiply this one. Simplify this one.
Then it should go to
That side.
right hand side.
Right hand side.
Okay, we can write right hand side first.
And x dot t both sides.
it can be equal to A dot plus, or we can X dot left and X dot right also.
Here.
This term
Also
we will move
right side
right.
and left side.
X dot, we added X dot,
Add X dot, there are
but also should be to another side,
X dot
plus
here.
this one.
This term will go.
Finally, unify this as 1 minus A dot. Here only simplification. One term times X dot. We need this. Sorry, not visible. As
So here X dot is in
or finally, we can put in this form. We
this,
can put
this two we cannot write at once. No? X dot is in the
X dot is in middle. We will stop here, of course. We will not continue future. Okay. So we analyzed two models for finding matrix inverse. Another models are presented here. We can investigate it. It will be in your GIAN material. Moore-Penrose inverse. It is first problem after matrix inversion to develop ZNN model for computing Moore-Penrose inverse. Here is error function 24, which we'll use in development of this ZNN model. We spoke that Moore-Penrose inverse is a unique solution of four matrix equations. Equation 1, equation 2, equation 3, conjugate transpose of AX is equal to AX, and equation 4, the same with XA. But no one of these equations is not used previously to define Moore-Penrose. Most popular is error function defined of properties of Moore-Penrose inverse. A star A tag equals to A star. Of course, transpose will be in dual case, we will use property A dagger, A star equals A star. Which of these two models are usable? First equation, A star A, we spoke. A star A is invertible. Second equation, A dagger A star equals A star, will be used when A star is invertible. We spoke about this. Here, we will choose one of these two models. Second model is defined according to an analogy. With selected error function defined right inverse of A. Who is willing to develop this model? Here is help on table. P of t is equal to A star of t, A v of t or x of t minus A star of t. E dot of t is computed in similar way. All is in analogy with the scalar model only. We have no commutativity. We have no commutativity. Huh? You want? Sure. Okay. Thank you. Dot of A. A transpose, we will find derivative of A and then make transpose. Of course, it is clear. We need term with. With dot. Yes, excellent. On left side. We will need to put v dot here and v dot to another side. This form is equivalent but appropriate for z. And after that, apply integrator. of t. V of t, left-hand side previous. And another terms are the same. One term is derivative of a. It is minus gamma error function. Okay, thank you. A star is invertible. Then we will obtain left inverse of A. It is also Moore-Penrose, but Moore-Penrose represented as right and left inverse. And in rank deficient matrix case, we will use well-known Tikhonov regularization parameter and define ZNN model in the same manner. Now, question is, what will be if we want to compute Drazen inverse, to approximate Drazen inverse? Here we use this equation. A star is aimed to computing Moore-Penrose inverse, which matrix is aimed to for computing Drazen inverse. What? A of course, we will replace Drazen, develop ZNN model, which will be really extremely complicated. There will be need to find derivative of AK, and it is because of non-commutativity, very difficult and complicated. We will have A dot, then A dot, then and such models are not considered. Such models are not. What will be if we want to compute outer inverses with prescribed this model for computing outer inverses? We spoke when we want to continue, we need to find A star. And then if we replace A star by A power k, we will, a difficult model, we skip this. But if we want to find outer inverses with predefined, so error function leads to outer inverse with prescribed range. Arrow make generalizations of known results about Moore-Penrose inverse. Then it is easier to manipulate with GA than with AG. We used assumptions in GIAN computing outer inverse. We used the same error function, but one assumption must be equal to rank of G. Solvable. But it is not because of problems with ZNN model. it is a linear matrix equation. GAX equal G. We will find such condition. Belongs to real matrices we can consider here of order m times n belongs to n times m matrices of rank greater than 0. Such error function GAX minus G for computing outer inverse. But this, in case if GA is not evaluation of this model. Because of that, when GA is left invertible or right invertible, GA invertible assumes now it means full Coleman rank case. Need to put this regularization term in all. It is in accordance with ZNN design. GA of T, okay. A of T, V of G, V of T minus G of T. Dot of E of T is minus gamma. E of T, of course, non-linear. But in this case, we will have no problems with invertibility of G. In any case, it is smaller than dimension M. According to matrix of dimensions n times n. And better is to apply GA when dimensions. Dual case M. When M is less than n. So E of T should be defined as X the same plus lambda in case if n is less than or equal to m, or Ag plus lambda I. Because of invertibility, but simpler model will be first if n is less than or equal to m, and in dual case another will be limiting value of our error function. In first case, x is equal to GA plus lambda identity matrix. G, according to ZNN dynamics, will tend to 0 when this expression equals to GA plus lambda E minus 1 G. In limiting to infinity, we will obtain solution tilde x, exact solution, in infinity, limit as t tends to infinity. And for small values of regularization inverse with prescribed range R of G, N of G. Null space will be equal to N of G. Again, lambda should be appropriately close to 0. As small, finally, according to my experience in one moment, future decreasing of value, which gives all approximately numerically best behavior. Theoretically, best choice is, here is development of ZNN model based on this error in developing ZNN models. Who is able here? This phrase. Okay. Can you try? Do you need white chalk? E of G is equal to, we wrote this, case, dual case can be developed in the same way. It is error function. Here is error function. G A used plus lambda E. Information according to lambda dot where is V of t times V of t. Okay, we can continue plus. We can continue with G A dot and then no lambda, derivative of lambda 0, no lambda. Matrix is constant value. Appropriate side. It is matrix computation. We have no commutativity. V will be from right. Then it will be constant, and we will use V dot.
So now
We used first dot. We used first dot of this term. The dot of this term is this one. Yes, V of t plus this term V of t, but from right. Take care about non-commutativity in matrix case. And finally equals minus gamma. In any case, we need this term left and all another term. This ZNN dynamic is given in implicit form. Typically, ZNN dynamical system is explicit form. Left-hand side of GNN dynamic. Here, models are implicit, but this may be applicable. Because of that, we used here regularization to obtain always invertible matrix. Inverse to Drazen inverse, then to outer inverses. Okay. Thank you. Again, matrix G must be of opposite dimensions. If A is of dimensions m times n, G must be equal to rank of A, and rank of GA must be equal to rank of G. It is not because of difficulties with ZN model, it is because of requirements of matrix algebra. Okay, we will stop here. We have small time for.
So the parameter lambda we choose, is there any method to optimize it to find the optimal? So again, in this the basic ZNN model, we again introduce we
Lambda.
can
Lambda should be defined from command line. Define lambda or use command line to define lambda.
So when we modify the ZNN model to finite K1, K2, so
AG, gamma, lambda.
a lot of parameter, and if we choose extreme ends, it will converge, but it will concur the lot of new.
All the parameters. Predict something for parameter gamma is important. If we ask really small values of gamma, 10 power minus 16, we can obtain instability. And possible that something with similar with Hilbert matrix will appear. GA must be inverted equals 10 minus 7, we will obtain results. Sometimes we can choose lambda equals 10 power minus 8 with almost the same result. And future increase result will not change. Minus 16 can lead to numerical instability. Sometimes will not. No one can predict if lambda equals gamma. As always, better convergence result with rank of G. Rank of G is less than or equal to rank of A. Initial state, as always. Best choice is 0 in. Thank you, Shaban.
What about that group inverse?
It is not so difficult because K is equal to 1. And it should not be problem because for group inverse we will have equation. We will have error function. I will put immediately error function here. Can you help me? Equal to 1. Square, or we can write, and then E dot is easily A dot A V plus A dot, we will collect it and write V of t plus A V of t, V dot V of t, sorry, I wanted immediate V of t minus is here. Every function requires minus. It is not difficult, easily can be developed. If index is 3, not model is more and more complicated. Do you have more?
In ZNN or even in GNN, when we are dealing with multiple parameters like lambda as well as gamma, is there
Gamma.
any, like, as you mentioned, like to find the, like usually what we do is we take small values of lambda and larger values of gamma. So is there any sort of framework for which we can actually do some sort of parameter estimation to go towards the optimal values of these given a particular problem, in a particular problem?
Eigenvalues. Huh?
Just for these parameters.
Just
parameters of
do you speak about possibilities to compute eigenvalues or no?
Not computing eigenvalues, sir. So like some sort of parameter estimation framework for these itself, like in these models itself, but
I didn't know some rules about lambda. There is no some theoretical result which will say for this class of problems appropriate lambda is defined in this way. For another class of problems, it depends on problem. In each problem we can try. Typically 10 power minus 6 should be enough. If not, you can try with smaller. Sometimes it is possible that we reduce the reduced lambda to find better solution.
In defining the ZNN model, can we update the ZNN model to incorporate specific properties of a matrix? Suppose it's a symmetric matrix, kind of that, to reduce the computational cost and fast.
After my presentations, many people ask the question about possibility to work with structured matrices. For example, if A is a Teplitz matrix, can we define appropriate ZNN model? Can we modify ZNN model in appropriate way to obtain better behavior? I think there are not such results so far. Not results so far. It can be job for young generations. You have only several questions. Thank you for questions. Okay. Thank you. Body computation. In this computer is included. Included? Prof. Predrag folder. Prof. Predrag. Folder with a lot of files.
Yeah, we'll keep this because the earlier workshop also very GIAN course. Please start your 2 hours tutorial class. Okay.
Thank you.
Thank you.
First of all, I want to answer to one made wrong computation. It is not true. Problem was of function sine of 3x minus 2 with respect to x. And we obtained 3 cosine of 2 minus 2. It is the same, because cosine is even function. Why Mathematica used some no property cosine of x is equal to cosine of minus x. We spoke that Mathematica as computer algebra system contains user-friendly environment where we can put our commands and obtain our results. This notebook is as our throughout. We mentioned difference between left column we presented numerical calculations, in right column symbolic calculation. What is main observation? With precision, single or double arithmetic. Symbolic computation work with arbitrary precision or can works on numbers. Symbolic calculation works on symbols. Here, X is undefined symbol, and Mathematica is able in symbolic computation we have possibility to make transformations and simplify expressions. There is possibility to work on trigonometric functions, symbolic derivatives, symbolic integration. We can do some simplifications. Here are more examples about example of numerical calculation. Of course, here we worked only with integers. There we worked with symbols, and the result is given in symbol. Also, we spoke that symbolic calculation can use function as input and work on this function and produce another function. Example of numerical calculation. And symbolic calculation. Here we have two symbols, A and B. Later we can define A and B, and this expression will change value. In general, it is numerical calculation gives numerical value, numerical appropriate value of two fractions. Symbolic gives exact value. What can we expect from modern computer algebra system? We can expect computation with arbitrary precision. Can expect computation with symbols and variables. Symbol means it is variable which is used undefined with not defined value. Computations with functions. For example, computation using functions such as sine, cosine, arbitrary function f. Our first example today is aimed to application of functions. Symbolic operations are available in differentiation, integration, factorization, simplification of algebraic expressions. And we mentioned such possibilities as computation of such very complicated expression. Here is x minus 1000 power 100, sorry, power 1000. Shift enter. If we press Shift Enter, we will obtain output corresponding to input. Mathematica don't want to work weights, wants to save this expression in symbolic form. As we write, and want to use such expression in future calculations, possible that such expression can be simplified. We can say Mathematica command is expand of percent. Here percent means last output. 2% mean output before last one, and so on. We have too large want to save our space. We will ask to show all. If we do this calculation on hands, it will take days and days, and finally we will make one mistake. It is expression. Here is example of symbolic calculation. Result is obtained in paid undefined. What Mathematica did only? Mathematica simplified 3x minus x in form 2x. Work with strings. I want to show that data types in Mathematica are diverse, are very different. A rational number is one possible input. Result is x equal dot means you should forget value of x. Now we can ask what is value of x, and ask what is value of x. We will obtain this version. It is changeable. We can go up and down across values. When we are not sure, and when we want we should type x equal to dot. It means forget value of x, which means undefined, but verify x is x. We can use command clear. Notebook. What can we do with mine? Nothing. Mathematica cannot do nothing. Can simplification of simplify. Simplify is available. Enter. Shift Enter. Cannot do anything. Well-known formula for integral of x squared dx. Can use palette to can make programming, type. I used from basic math. Here is integral of x integrate. We want to integrate x down 2 in power, enter, and again we will obtain the same value. So if you want, you can type expressions as it can be done in Word. Result is symbolic pi. We can ask then can ask value of pi with arbitrary number. I will delete this expression to save space. With property I square with basic assistant, I think here is -1. Or we can use capital A rationalization of P, 10,000 digits. Then we can ask digits, but it is with precision 10 power -5. If we ask approximation of pi with respect to corresponding rational number, approximately 22/7. Logarithm function is there. If logarithm, and we obtained 10 in this expression, 40 digits of precision. With respect to undefined A, blue color says this A logarithm function, it is natural logarithm of A by natural lists. If we want to work with vectors, to work with matrices, it is necessary to be familiar with lists in Mathematica. For example, such expression, transpose of T one level more. There is a vector column. Each row contains only one element. Here is one row with 5 elements, and there are 5 rows. We can ask parts of T. We can see from definition of list T. Here means corresponding number from the end. Part of T minus 2 means second element from the end. Right from left, and second element from the end is 40. To include a new element in list in beginning, append is for including new element in the end. Here we want to include value 1 in beginning stayed the same. It means that function prepend is not destructive, cannot change first argument. Opposite to this, prepend 2 is prepend 2. Here is down. Result is the same. But later, if we ask what is value of T, we can see that value of T has been changed. Sort list is one of available functions. In sorting, then ASCII codes will be used in this sorting. Function make expansion with respect to variable. If we have polynomial of two variables as here, we can choose expansion with respect to first variable or to second variable. Simplify is most powerful function. We can make simplifications of some algebraic and another kinds of expressions. For transcendental also, simplify of square root of x0 as constraint. Differentiation, break expressions, here we want to solve quadratic equation ax squared plus bx plus c equals 0. With respect, x is and y are green. Okay, not this here. If one of variables x, if variable x is black, it will mean that x is already defined, and we cannot expect solution with respect to x. Here variable one or more must be included. So I skipped this blue, x is green, it means all is under control. We have only symbols. Possibility to solve high order polynomial equations. Some values here are real, first two values are real, another four values are complex values. If we ask complex values corresponding to these solutions. Then powerful functions solve and reduce. Both functions we can use to solve equations or to solve system of equations. Reduce is able to solve system of inequalities equation under constraints. In first example of solve, we want to solve to x and y. Interesting here is that a and b are symbols, undefined symbols. Can solve system of equations. Here is one equation. X greater than 0, y greater than 0, and want that x and y are real numbers. Find instance is appropriate if we tried with solve, tried with reduce function. Then we can ask find instance function to give us one instance, to give one particular solution. It is useful sometimes ask particular solution you are interested. If something is find instance of one inequality of type greater than with function sign of two parameters. It is one particular solution. We can try with another function. I don't know why use this with find instance. Solved. It is a general solution. Really useful tool for mathematicians. What will solve say? Sometimes I lose cursor and cannot find. Solve cannot qualities. Then recommendation is to use reduce function. Using this function you will obtain sometimes. If reduce cannot find solution, exact solution, you can try with function finding. Here is one example for one important memoization. Are you familiar with number of recursive steps can be very theory of algorithms. We can find two approaches in solving this problem with memoization. Memoization means that I will store previously computed values and will not compute from beginning. This dynamic programming, Mathematica. It is memoization. Mathematica is able to trace memoization. Here is one simple definition. I want first to clear fib, variable fib, symbol fib, which will small f. I want to avoid possible definitions in package Mathematica. If you use fib in any case, but fib was blue, which means safe, we need two initial values, and then we need with Fibonacci sequence f0. I will use f shortly here. Next is iterative definition, and Fibonacci. So Fibonacci sequence is defined by 1, 1, then here previous of previous with some. Can you see this? Not clear. Light. With light is better. I will write big with 2, 3, 5, 8, 13 rule. And I will use such a recursive definition of function fib of function in Mathematica. I must put underscore in argument. Probably I changed something in definition of fib. I will use start from beginning. One and one are in beginning. Then we have using F0 and F1 we can compute F3 recursive rule. And now we have one. Computed using F3 and F4. Not only complete multiple values, multiple defined values. There will be need to compute F7 2 times. And strophic. Memoization. Say Mathematica. Fib. It is delayed assignment. We will use 2 dots. Two initial values. 2. Fib of 7. Fib of 50. Okay. Here is used dynamical programming. Fib of n. Fib means it is function. Fib of 70. Better and better computers, and in previous computers it 700, and we can see that this cell is still under. Now we will use to stop this evaluation. Stop evaluation can be used, or Fib of n equal there is possibility to numerically here one possibility to generate. Here we want 3 times 3 matrix and so on. Matrix form of this determinant inverse M without simplify. With simplify, think. Looks as wrong. M times inverse of M. We will obtain identity matrix if we use simplify. I think for inverse is not necessary. Obtain identity 3 times 3 matrix. It is benefit of simplification. So if you work, recommendation is to use frequently simplify function. Bigger and bigger, and you will not obtain what you want. Here is one kind of logarithm function. Answer is logarithm of z gives natural logarithm of z base e. Logarithm b. Then I can go to help, detailed help. Here is a question with 2 question tags. I ask more details about logarithm function. Attributes of log are list table. Numeric function can be applied to arbitrary list, and then log will be applied element-wise to element of this list. Cannot make another definitions of function log. Functions which start, which symbolic, which names start with log. Log, star as joker, arbitrary can be. And Mathematica gives list of standard functions which start with log. Random number generated using function random. Table random. Give me random numbers from 0, 1 interval. It will be vector with 4 elements. Comma 3. Okay. Requires slightly different, don't. Here is defined parameter is defined using underscore. Name of this parameter is x, defined as x squared. F of 2 is, of course, 4, but f of s is s squared. Later to to numbers and can apply to symbols. Here is one application to number, function to number, integer number to real number, have application to symbol, and have application to function. In this way, we can define start again with fib of 1, fib of 30 timing. I asked timing, and here is time. Fib of 300 timing. Fib of 500 works. Can be complicated even for computer. Why computation of fib of? We have many recursive calls. And after all, even simple calculation cannot be perfect. Definition of, cannot find my cursor. About 300. Fib of 3000. The same time. Fib of 30, probably almost the same, because we use previously computed and stored values instead of recursive. Rational number corresponding to P with arbitrary precision, n of P high. If we use bigger precision, we will obtain better approximation with a rational number. Given as this product, polynomial is with respect of variable x. This polynomial, it is a result obtained after multiplications. Factor integer function, and here is factorization. How can we, explain this result? This result means first integer which divides 52 is 2 squared. Then we can ask if numbers are prime or not, plus I. Possibility to make programming in Mathematica. Mathematica is not only to make for cycle, possible that Fibonacci still works. Here is the result. There is one initial value, and this for cycle works until I is less than. We will ask a question is equal to 3, then only continue. It means we want to skip evaluation with I equal 3. If I is equal to 2 times equal 3, continue. We obtained 1, 2, 4, skipped value 3. Next function. Here, next function is applied to arbitrary function f, undefined function f, in what we want. Here is function. Applied function here is defined as pure function. With respect to z, we want to print z2 and apply this function to 67 value and obtain successive values from 67, 33, 16 to 0. Generator of complex numbers, random complex number, within this interval. Smallest value is minus 10, minus 10i. Biggest value is 10. For our interest, the most important will be manipulation with lists with matrices, but I wanted to present some introduction so that you can trace possibilities. In linear algebra, we should introduce work on lists. Here is one-dimensional list, it is vector. Two-dimensional lists as matrices. Rest. Element of list can be arbitrary. Here, element of list are symbols, expressions. We can include new elements in beginning or in the end. L should be defined as list. L is defined here as list A, B, C, D, but A has been defined previously. Black color for A says A has been defined, B, C, D, symbols B, C, D. We can ask to prepend X in list L. Prepend means add symbol X in beginning. And here X is in the end of list L. But what is value of list L? Using this expression, append X, add x and the end of list L, but list L is still with the previous value. It means function append is not destructive function. What is L then? With x. Append to destructive function. Only append is not destructive. Take L. First element is list. Second and third element are atomic expressions defined as unevaluated symbols B and C. We want to and define T as such two-dimensional list. This two-dimensional list contains two rows. First row is A, B, C. Second row is D, E, F. Then if we ask Mathematica to give us element in intersection of first row and second column, in this way we will not obtain result. It will be definition of new eight values, elements, rows or columns. We must use double brackets. Then the result is element in intersection C. Second column in ABC is B. We can use replace part to replace elements of matrix. Put X in positions. Position 1 and position 4. Command. Do function which makes oh my God. What I remember. And we recursively can compute. Final result is T. Fixed point function. Continued fractions. Name of previous structure is continuous structures. Continued fraction. We can ask first element of vector. It is or can ask first and rest of matrix. This V is defined as matrix with one row with elements 1, 2, 3. First element here, so rest of matrix V is empty list. It is list without elements. Here is definition of symbolic matrix. Matrix form is also always useful. We can use matrix form to trace, as list is not so easy to trace. We can use matrix form. And then don't forget to use two brackets to make access. Here is approach to first row. We can ask, we want a submatrix which contains from first row 1 to 2, and then in second from second to third element. In first row from first to second. Sort function. Rotate left and right. Apply function is confirmation that arguments in package Mathematica can be another functions. We can define function. We want to apply function plus to list A, B, C. Result will be A plus B plus C. We will obtain A plus D. We will make addition of first elements, then B plus E, and then C plus F. Then Mathematica said that we cannot combine 3 and another one of length 2 if we change length. Here are some logical expressions. Now in our case, x is undefined, so ask question if x is equal to 4 will give different result. It is not a result true, and I will save this question in symbolic form, x equal 4. Later we can define x ask the same question. Now result is false. Is that some parts or complete expression can stay unevaluated. Two times x equal 3. X is defined as 3 gives 2 times true. Q equals false. Then we didn't use this. Q equals false. Then A equal 0, if not A is equal to 20. So command A equal to 20 is performed. Value of A is also 20. about linear algebra. Here is of matrix which is given in symbolic form. Finally, we used A, 1, 1, 1, and so on are unevaluated symbols. Probably clear will help. And such defined value appeared here. So clear all helped. Now A is blue, and we obtain result of determinant in symbolic form. Here is one fine possibility form. And in this way, we will obtain possibility to use this expression immediately in your LaTeX file. Use practically command tech form and later select, copy, and paste in your LaTeX, and you will obtain the determinant of this matrix in symbolic form. Inverse of matrix with many variables with simplify. Small difference. Matrix rank of A, B, C, D. If you ask I will use postfix notation for D are independent in general. Of course, later we can change this to 2 and ask now what is matrix rank of this matrix. Of course, will be 1. Again, initially, mathematics are with different values. Matrix decompositions are available in exact form. Cannot find my cursor. Here is. I will ask help about case sensitive. On numerical matrix. Exact matrix. If numbers involved in matrix are exact or symbols, Mathematica will give. If results are given in give result in also in numerical form, matrix form on last result. And now gives 2 matrix forms. 2 matrices given in matrix form. It means that of course we need two matrices Q and R. Will give a result. Q is given in symbolic form. Give me numerical value. Result looks not identical with matrix A, but if we use function simplify in the end of this expression as matrix A. So again, clear conclusion is that function full simplify and simplify are very useful, and you your expressions. Q is unitary. Q times transpose Q is identity. There is a function singular value decomposition with such long name and with initial capitals. Left we used list of three functions, U, W, V. U and V are left and right unitary matrices. W is main diagonal entries with singular values, another element 0. We know this from previous computation. Singular values, square root of 10, another are 0. U should be equal to A. It is elementary property of singular value decomposition. Ask two unitary matrices, U and V, and ask matrix. Matrix W is given in form one by square root of 10. All another entries are 0. Should be here 0. We assume that 0 Moore-Penrose is 0. It is definition of Moore-Penrose of 0. And another are 0 blocks. We can compute Moore-Penrose using SVD and can compute using standard matrix function. First way to compute pseudo-inverse was to multiply V pseudo-inverse of diagonal matrix, which is easy, and U. About possibilities of many programming languages to compute Moore-Penrose inverse. Presented possibility to generate matrix using random numbers, random real numbers. This matrix L is defined as matrix with entries where I goes from 1. 1 can be put here and can state here, not necessary. 1 is assumed, and J runs from 1 to 4. Random number generator. if we run this expression, if we evaluate this expression different because of pseudo numbers included, L of 1, L of 1 will give first row of matrix L. Approach to arbitrary row of matrix. Don't forget to use double brackets here. First row of transpose matrix of L. What we obtained, first row of transpose rows of transposed matrix, we can make approach to columns of A. Take function, give me first two, second and third row. Here take, here drop. First and last column. In this way we can manipulate with arbitrary row, arbitrary column available here. This talk and use later. Also, Safik, probably it will be possible to put on GIAN site. Here is possibility to include one row more in matrix. Here we use only transpose, join and transpose. We will join and transpose. We will add new row, but if we use transpose, join and again join in function which can add one new element in list. Here we used vector form of join. Values can compute eigen vectors, eigen systems. Don't forget that you have very rich, not this, here is, not visible. Help is not visible, here is in black. Questions about mathematical functions. It is impossible to know all functions in advance in mathematics. There is really impossible, finally not necessary to, to know all standard functions. You can reach help as you want. You can type here what you want to simplify your research. So, I think we finished with short intro in linear algebra, and in future we will focus on applications in linear algebra, matrix vector computations, and so on. You can ask.
So now the time for questions. If you have any questions, please. Things he has discussed about the Mathematica for the beginners. Yes?
Symbolic calculation is
Symbolic
useful.
calculations.
And you can obtain hypotheses in this way,
There are a lot of
even symbolically.
yes.
If L is defined using symbols, we can apply eigenvalues, and Mathematica will say Mathematica in
All
verifying
such things you can calculate.
in
from-
verify some combinatorial identities.
Okay. Good. If no questions, please give thanks to.